Hello everyone, in this lecture what we're going to do is write preprocessor directories. Now you do not need to know what they mean, you just need to know how to write them in the first few lectures. In the later lectures I will teach you what they mean and I will teach you how to use their functionalities. So preprocessor directories are a C inbuilt directories that have various methods and other functionalities we can use. For instance, if we want something from the keyboard or the input, we use various preprocessor directories. One of them, the most common ones, are stdio.h and stdlib.h. So let's see how we write preprocessor directories. The first thing you do is type in hash or shift 3. Then we type in the word include. Now include is a keyword, so include. So when you write it, its color is going to change, and that's how you know you did not make a mistake in your keyword. Whenever you type in a keyword, their colors change in a notepad or any other editors. Then you leave a space, you type in a smaller than sign, and you type in your directory name, which is going to be stdio.h, then a greater than sign. The next preprocessor directory we are going to write is stdlib.h. So the first thing we do when we write a preprocessor directory is type in hash, then type in the keyword include, then leave a space, the smaller than sign, then the directory name, and then the greater than sign. So that's it for this tutorial. I will see you next time. So now we're going to write a main method. A main method is a method where the compiler looks to for compilation. So basically, when you are compiling your program, it looks to your main method and then compiles. It doesn't look at your other code, it looks at your main method. So here is how we write our main method. You type in the word main, then you type in brackets, these brackets, and then you type in the braces. And all your code for the main method should be in the body of the main, between these braces. Okay? Now every main method has a body. A body is important because if you don't have the body, there is no code, or the compiler sees no code in the main method and it doesn't have anything to compile. So the first thing we're going to do is we are going to write our hello world program. How we do that is we type in the printf method, which is print, printf. Okay, I'm just going to show you. I'm not going to use the Sublime Text extensions for those so you understand. So let me type it again. printf, and we are going to create brackets. And when you write your hello world, what you need are these two strings. And whatever you want to output should be in these structures. So make sure you have those whenever you're typing something down and you want to print it out. And let's type hello, comma, world. And once you're done with your printf function and your string that you want to output, you enter a semicolon. What a semicolon does is it tells the compiler that the statement is finished. So this is basically one statement in your main method. So let's compile it and run it. Hi guys, in this tutorial I am going to teach you about if-else loops. The structure of if-else loops goes like this. You type in if, then you type in brackets, and then you type your braces. In the brackets, you write the condition that you guys want to check for. So basically, if you want a program that checks for whichever number is higher, then you type in if num1 is greater than num2, then print num1
make sure you
is
save
greater
your code.
than
So let me
num2,
save,
and
then go
else
to command prompt and
you type
in
f
my compilation statement in the command prompt. But
is
look,
greater
my directory of this code is saved at the desktop, so I cannot just type in gcc.
So basically, once you check for that condition, based on that condition, it's going to execute one of these statements. So if num1 is greater than num2, it's going to print that. If it's not, then it's going to go to else and print this statement. In the else, you do not need a condition because it will be illogical.
So I am going to write down my
you can only check for condition in the if-else loop, in the if condition. And now let's make sure you always have your braces. Don't ever forget your braces. And let's save it, and let's run it.
Be part 2.
Compile,
and look, there are no errors. So now
enter num1, 25, enter num2, 26.
Compile
num1 is 25, num2 is 26, num2 is greater than num1. And
port 2.
That is our if-else loop.
It says the num1
it always checks for a condition. If-else loop is all about your conditions. If one of the conditions is met, it executes the code based on that. You guys also need to know one more thing.
So
when you're writing an if-else loop and you only have one statement after your in your if body, then you do not need these braces. But it is always a good practice to write your braces.
We can do that, and now it's going to print those values.
It makes
so let's compile it again.
The compiler.
And let's run the executable.
I'm sorry. It takes the compiler a little more time
to
detect an if-else loop
so
if you do not have those braces. But you can also do it without those braces.
Compile it again.
So let's save it.
Run the executable, and now you can see how num1 is equal to 100 and num2 equals to 20,000.
Num1 is greater than num2. But make sure you always have those braces. Even if it works, it's a good practice to have your braces.
The variable values
save it again.
And let's see what happens. And
run it
print
again.
them again so you can see how it overrides.
25.
So let's
22. Num1 is greater than num2. Now, this loop will fail if you have the same values for num1 and num2. And let's see how that works. Let's check it out. What if I enter number 22, 22? Look at that. It failed this.
Look, the first thing
I entered num1 to be 22 and I also entered num2 to be 22. It prints it out and then it says num2 is greater than num1. This is what is known as a semantic error. It means that there is something wrong with your code. It's nothing wrong syntactically. Syntactically meaning all your code is typed well, it has good values and everything, but there is a problem with the code itself, and that semantic error you have to detect, and we're going to understand that errors in the later lectures.
The values that we stored before that.
Hello everybody, in this tutorial I am going to introduce you guys to what is known as logical operators.
Let's see what happens.
Now I know it's a big word, and if you don't understand it, you do not need to worry about it right now. All you gotta do is make sure you memorize them by heart. So take a second, pause the video and memorize these logical operators by heart. I am going to show you how to use them in a few seconds, but make sure you have memorized all these logical operators, these 4 logical operators by heart.
It was too big.
Now that you have probably memorized these logical operators, let's use them in programming. So the first program we are going to write using the logical operators is to check if the age you entered is
let's compile it again.
A teenager or not. So basically,
compile
if you are a teenager, your age is greater than or equal to 13 or less than or equal to 19.
And look at that. The first thing, it printed out num1 and num2.
Let's write down our program. The first thing we are going to do
but those
is
values are
declare a
different because they got overridden
int
when I assigned them new values.
Second thing we're going to do is write down the prompt.
Doesn't look too pleasing. It's all in one line. You want to change that. We want to have different lines for different variables and their values.
Don't forget the semicolon.
What we can do
then we are going to say
go to
that
our print function, and at the
value
very end
that
of
the
prompt,
user entered with the format specifier in the symbol
and what that's going to do is
address age
give a new
semicolon.
line.
Now comes the major part. Now we want to check if this age is greater than or equal to 13 and it's less than or equal to 19. So we have two conditions to check. So first let me write down the if loop. If. Now we have to write these two conditions down. Remember the logical operators. Look at your notes. We're going to say if
now look at that.
Age
it changed
is greater than
before we added the new line \n, it looked like this.
To
but
13.
Now, after we added, it looked very pleasant.
Now
actually.
this is the logical operator that we just saw a few seconds ago.
Whenever you want a new
and
line, if you want a tab, it's
less than
\t
or equal.
So that's very useful, and we're going to use
to
that
19.
in one of the later lectures.
Then print f. You are a teenager. Else you're not. So else you are not a teenager. Don't forget your braces. Okay? Alright. Now, the important thing here in this program to remember is is to check if this condition is met. So whenever you enter age, the compiler is then going to compare that age to 13 if it's greater than or equal to 13, and this logical operator translates into the word and it's less than or equal to 19. If both the conditions are met, only then this statement is executed. If only one condition is met and if the other one is not met, then this condition is executed. This statement is executed. So there's a difference. Whenever you're using an AND operator, both these conditions have to be met. Otherwise, this statement is not going to be executed. Now, if you have, let's first compile this so you guys know what I'm talking about. Let me open this command prompt. CD desktop. Okay. GCC logical operators .c Oh, it compiled without any errors. So let's execute the executable. Logical operators. It's asking for age. Let's see, 25. You are not a teenager. Now let's run it again. Let's say 18. You are a teenager. See? So basically it's AND. Now right now we're using the AND operator. Now what if we don't use the AND operator and we use the OR operator? But let's write another program down for that so you guys know what I'm talking about. So now let's change this AND operator to an OR operator. Let's see what happens. Now, whenever a compiler sees an OR operator, it takes a look at this condition and this condition, and it checks whether any one of this condition is true. So if any one of those conditions is true, then this statement is executed. Basically, when you're using an AND operator, it checks for both of the conditions to be true. But whenever it's using an OR operator, it only checks for one condition to be true. So let's compile this. Now we gotta compile it again. Enter age 12. You are a teenager. See, 12 is not a teenager, but it still says you are a teenager. Why? Because when the compiler looks at this condition, it says, is age greater than or equal to 13? False. And then it checks this condition. If is age less than or equal to 19? True, 12 is less than or equal to 19. And then it prints out that you are a teenager. It only needs to satisfy one condition and to execute whatever is in the body part of if. So remember, OR operator only needs one condition to be true. AND operator needs both the conditions to be true. So that's it for this tutorial. In the next tutorial, we are going to look at the next two logical operators, which are the equals to and does not equal to. Until then, good luck. In this lecture, we are going to look at the two logical operators that we did not look at in the last lecture. I hope you memorized them. If you did not memorize them by now, I suggest you pause the video and memorize them. Now, what we're going to do is we're going to write a program to check if num1 is equal to num2. And then we're going to write another program which is going to check if num1 does not equal num2. Basically, by using the operators. So the first thing I did in this program is declare a variable num1. Then I declared a variable num2 and assigned it the value 5. Now, this equal sign is an assignment. It means that num2 is assigned to the value 5. It's very different than typing equal equal. Now this equal is a logical operator. This equal operator is a checker, and you're going to understand what that means in a second. So here I asked the user for the value of num1. Now let's write down an if loop. If num1 is equal to num2, then print that num1 is equal to num2. But you have to understand, whenever you're writing a loop, especially an if-else loop or just an if loop, you cannot set num1 equal to num2. Remember, this is the assignment. This is not checking if num1 is equal to num2. So this statement is completely illegal. You need to write equal equal. If num1 equal num2, it checks if num1 is equal to num2. It doesn't assign it. Whenever you write down num1 equal num2, it basically says num1 is now 5. Or num1 is whatever the value of num2 is. It does not mean it's checking. In a condition, whenever you're writing a condition, make sure you have logical operators. And a lot of people make mistakes with logical operators. Even experienced coders make mistake. Whenever you're writing an if-else loop or loops, make sure you have this logical operators. Do not assign it a value. I have seen so many mistakes like this. I cannot stress this enough. Do not assign a value. Use your logical operators. So now we have used our logical operators. Now let's write in the else loop. Else, if num1 is equal to num2, then we know that num1 is equal to num2. Else, print f num1 does not equal to num2. Okay, let's save it and let's compile it. cmd cd desktop gcc logical operators .c logical operators. Ooh, there's an error. I forgot a semicolon. Okay, let's correct our mistake. And there's another error. No, there isn't. It's just saying that you forgot a semicolon before this token. Okay. Now let's compile it again. Oh, there's an error again. Oh my god, I forgot to write the printf. See, here I'm not deleting my mistakes for a reason. I want you to understand that even experienced coders like me make mistakes, and you need to catch them fast before it ruins your entire program. Let's save it. Let's glance at one more time to make sure we don't have any more mistakes. I don't believe we do, so let's save it. Oh my god. Let's compile it. Enter num1. Let's say num1 is 25. Now it prints out num1 does not equal to num2 because when I entered 25, it went to this loop, if loop. It says, is num1 equal num2? It's checking, is the value of num1, which is 25, equals to the value of 5? It isn't, so it goes to the else part and it prints out num1 does not equal num2. Now let's enter, let's run it again. Now let's enter 5. It says num1 is equal num2 because num2 is assigned 5, and when they compare it, their values are equal, and that's how the logical operator for equal works. Now let's look at the logical operator for does not equal. Let's delete the if-else loop here. Now let's type it. If num1 does not equal num2, then print num1 does not equal num2, else print num1 does equal num2. Now the logic behind this loop is that whenever you enter the number value of num1, it checks if num1 does not equal num2, then it prints out this statement. If it does equal num2, then we know that num1 is equal to num2. So basically, it's very simple. Let's save it. Let's compile it. Let's enter the value of 25. Num1 does not equal num2. Let's run it again. Let's enter 5. Num1 does equal num2. So that's our two logical operators that we used. I hope you guys understand it. If you have any questions, let me know. Otherwise, I'll see you next time. Hello everybody. In this tutorial, I am going to introduce everybody to a ternary operator. It's basically an if-else loop, but a different version of it. You don't need to use logical operators for it. Whenever you have something simple to write, you can use a ternary operator. So let me just introduce you guys to that. It basically has a syntax of expression 1, then a question mark. So basically it's an if-else loop, but a different way to write it. So the first thing you do is type in the condition you want to get checked. If that condition is true, then expression 2 will be evaluated or executed. But after expression 2, make sure you write a colon, not a semicolon. And if the condition is false, expression 3 will be evaluated or executed. And then after that, make sure you have a semicolon. So basically, this is a structure of a ternary operator. Let me give you an example so you guys know what I'm talking about. Okay, let's just use this, and then num1 greater than or equal to num2. Num2 question mark printf num1 greater than or equal to num2. Don't forget the colon. Remember, it's not a semicolon, it's a colon. And then you write down the expression 3, printf num1 does not equal to num2. Now let's save it and let's compile it. Compilation has no errors, so that's good. Let's execute the executable. Enter num1. Let's start with 500. So num1 is greater than or equal to num2. Remember, num2 is 5, and we did not use the if-else loop. We used the ternary operator. So whenever you do not want to write the whole if-else loop, you can use the ternary operator, and the syntax is so beautiful. So this is a very important operator to remember. Make sure you have that in your arsenal, and I'll see you in the next tutorial. Hello everybody, welcome to this tutorial. In this tutorial I am going to introduce everybody to the while loop. Now the while loop is a very important loop. It's basically a loop that is used to check for the condition over and over again like every other loop, but only the structure of it is a little different. So first I declared a variable called count. Let's assign it the value 0, and then while count is less than or equal to 100, print count. So, and then we're going to increment it, count plus plus. So what we did here was we declared the variable count of type int and assigned it the value of 0. Then we made a while loop and we told it to continue running until the count is less than or equal to 100. And then we said print count, and every time after you print count, increment the count by the value of 1. So let's save it and let's compile it. No errors. Look at that.
Now, I know this is not pleasant, so let's make it pleasant so it is more understandable. %d count equals %d, comma, then let's just instantiate a new line, save it, let's compile it again. Okay, so here is the count. It started from 0. It printed 0, printed 1, printed 2, printed 3. So the compiler instantiated count to 0. Then it went to the while loop and it printed out count, incremented count by 1, and it printed it out. So this while loop kept running until the conditions were true. As soon as the condition was false, it stopped running, because when count was equal to 100 or less than 100, it printed out count. As soon as the count hit 101, it stopped executing. It did not even print. So basically, this is the while loop. It is very simple, I know. In the next lecture, we are going to introduce everybody to the do-while loop, which is also simple. A do-while loop is basically used for printing out the menu. You'll see what I'm talking about in a few minutes. Hello everybody. In this tutorial, I am going to introduce everyone to the do-while loop. A do-while loop is a loop that has a structure similar to this one. We type in do, and then we type in the braces, and then in the end we type in while, and we check for a condition. See right there, and after the while, don't forget to write the semicolon. It is very important in a do-while loop to have a semicolon in the end after the while condition. The difference between a do-while and a while loop is that in a while loop, the loop checks for the condition in the beginning, but in a do-while loop, it checks for the condition in the end, and there's a huge difference in that. So let's check it out. The first thing we want to do is we want to print out the value of count. So count equals %d, save it with a format specifier, a new line, and then print it out. Semicolon. And then let's increment count by 1 and a semicolon. What we did here is we typed in the printf function and we printed out the count, the value of the count, and then we incremented the count by 1. But we still have to write our while loop condition. What we do is write down the condition in the end. So let's type in while count is less than or equal to 10. Make sure you have the semicolon after the while loop. So what this is going to do is it's going to go to the do while loop, and it's going to print count, then it's going to increment count by 1, and then it's going to check if count is less than or equal to 10. So basically, it's going to be executed at least once without checking the condition, because the condition is in the end, and you're going to just understand it in a second. I know if you're confused, that's fine, don't worry about it. I'm going to clear everything up. Let's make sure we save it, compile, execute, and look at that. Now, it started from the 0, printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It went until 10. Now, what if we delete this less than or equal to sign? Let's save it and let's compile it again. it goes up till 9, right? Let's compile it again. CLS, clear the screen, compile, execute. Oh, there's a problem. Oh, I didn't save it. Let's compile again, execute. Now look at that. It's the same thing because we did not change anything. Now let's change this condition. What happens if we change the condition? Now we want to check while count is less than 0, continue doing this. So in basic strategy, we know that it cannot compile this because count is equal to 0, and the while structure is telling us that if count is less than 0, only then compile this. However, when we save it and when we compile it, it says count is equal to 0. Why does it do that? It is so wrong. It is not wrong. You have to understand the structure of do while loop. It doesn't check for condition in the beginning. It checks for the condition in the end. So basically, these statements are going to be executed at least once before the condition is checked. So always, whenever you're writing a do while loop, make sure that whatever the statements are in there, you want them to be executed at least once. And that's the do while loop. Thank you for watching. I'll see you next time.
Hello everybody. In this tutorial I am going to teach everybody about for loops. For loops are very useful for iteration. So if you want to check various conditions by iterating, we can use for loops. But right now that's not important. In this tutorial I'm just going to introduce everybody to the structure of for loops. So the first thing we're going to do is we're going to declare a variable count. Then this is how you write a for loop. We write for, then brackets, and inside we are going to write the iteration. I declared the variable I, so the first thing we do is we tell the for loop where to start. So I equals 0. So it's basically telling to start from 0. The second thing we want to do is we want to say where does I want to end. Actually, you know what? Delete I. I want to make it really simple for you in this tutorial so you guys understand the basic structure. Let's start with count. Count equals 0. So we're telling the for loop to start from 0. Then we're saying check until count is less than or equal to 10. So this statement, the first statement, count equals 0, is telling the for loop to start at 0. And the second statement, count equals less than or equal to 10, is telling the for loop where to end count. And every time you add or increment count by 1. This is how a for loop is structured. You basically tell the for loop where to start, where to end, and what to increment every time. And let's just write down count equals %d, and then the count. Make sure you have a new line to make it pleasant, and it's telling count to go until 10. Save, go to command, let's clear the screen, compile. Oh, there's an error. Okay, I forgot a semicolon here. Make sure I have a semicolon here. Guys, make sure you don't forget your semicolon. Let's compile it again. Let's run it. Okay, so it went until 10 and then it stopped. So basically it starts at 0, ends at 10, and every time it increases count by 1. We did this in the while loop, but in the while loop we had to put the increment in the body part. For the for loop you don't have to do that. For the for loop you just need count in the conditions bracket, And make sure you don't have a semicolon after this, because that's not the correct syntax. And that's how we use a for loop. Now the for loop has tremendous advantages over every other loops. I promise you for loops are the most prominent loops while you're coding. So let's understand what for loops do. We're going to look at some advanced for loops uses in the later lectures, but right now make sure you have the structure of the for loop down.
Hello everybody. In this tutorial I am going to talk about break statements. Let's just write the code again so you guys know what I'm talking about. So first what we're going to do is type in our variable counter. Then we're going to write a for loop and we're going to iterate counter from 0 to 10. We want the counter to end when it's equal to 10 or less than 10, and then we're going to increment counter by 1 every time. Then what we want to do is we want to write an if loop, and we want to say when counter is equal 5, then break. Oops. What this is going to do, this statement is going to do, is it's going to break the whole loop, the for loop, and come out of the for loop. So to indicate that in the for loop, I'm going to write print. I'm going to print out counter every time so you guys understand what I'm talking about. Write down your format specifier. It's a good practice to have a new line. Counter, a semicolon. Also, what I want to do is in my main method, I want to have another variable, another print prompt, so we know exactly where we are in the whole program. Alright, let me save it, and let's compile it. Yeah, I changed the color of my command prompt. I don't like it. I'm going to change it after this tutorial. So let me... Okay. I'm just going to have to write it down again. GCC, the file name, which is logical operators.c-o, logical operators. And it compiled without errors. That is amazing. Now we have to write down the executable name, logical operators, and here you go. Look at that. Every time when counter was 0, it didn't even look at this loop because counter does not equal 5, and it printed out the counter value. It did that until 4, but as soon as the counter was 5, it just broke out of the loop, and it broke out of the for loop, and it came to the printf function and says, now I'm in the main function. So this statement, basically what it does, it breaks out of your for loop. Now if you have double for loops, what it's going to do is it's going to break out one of those for loops. We're going to talk about that in the later lectures. Don't worry about that right now. And now what we're going to do is we're going to talk about the continue statements. So if I just remove break and type in continue, I want you to see what happens, and then I'll explain it. Let me clear the screen and let me compile it again. And here, this is what happened. The counter printed itself until it hit 5. As soon as it hit 5, the continue statement was executed, and what happened was as soon as it hit 5, it did not print 5, because as soon as it had 5, it did not execute any of the code in front of it, and it skipped it. So basically what continue statement does is it tells the loop to continue the loop, but not following the body after that when that condition is met. So whenever you have a continue statement, make sure in that loop you do not want that code to be executed that particular time. Now same goes for continue too. If you have double for loop, make sure you have continue in both individually and not just one continue. It doesn't work like that. So we're going to talk about that in the later lectures. For now, goodbye and see you. Alright everybody, in this tutorial what we're going to do is print this pattern out. Now before we start writing the code for this, it is very important to understand the logic behind any code that you write. So we are going to start with this pattern. As soon as you see this pattern, you can realize that every row has the corresponding numbers of stars in them. However, every row after that has a line to be entered because each row has one star and there's a line. And then there's two, the second row has 2 stars and the third row has the 3 stars. And the row number also corresponds to the column number, so fourth row has 4 columns. Therefore, this code is going to require 2 for loops. The first for loop to iterate through the rows and the second for loop to iterate through columns and printing out this star structure. So let's start by declaring our star structure. Now you can declare any structure that you want. I'm just going to declare a star structure to make it easier for you guys to understand. Then we need the row and the column numbers. Then in this tutorial we're only going to print out the five rows. So let's declare number of rows equals 5. Now we can also ask for the user input and print out whatever number of rows that the user want, but just for simplicity I'm just going to use the number of rows till 5. Then the major logic part kicks in. Now we're going to declare our for loop. The first thing we're going to do is type in our row. We want the row to start at 1. We want the row to go until it's equal to or less than the number of rows, and then every time we want to increment row by 1. Now this is only looping through the rows. We need something to go over columns. So this for loop is going to be inside the row for loop. So let's declare that. Let's start our column to be at 1. Then column has to be less than or equal to the rows because it cannot be more. Look, every row corresponds to the number of columns, so it can't be more. If it is, then it's an error. So make sure you always have less than or equal to sign whenever you're trying to print out a pattern like this. And then what you need is column plus plus, an increment statement. Now what we're going to do is print out this structure. So let's just type in the printf function and let's type in format specifier for the character variable. Remember, it's %c for character, it's %d for integer, it's %f for float or double. Now let's type in our variable name. Oh, it's inside. See, that's a mistake. Make sure you never do that. And if you do, please catch it fast so your program doesn't crash. star. Now remember, this is only going to print the number of rows and columns and its correspondence. We need an enter key here to have a structure like this. Let me just show you and then it's gonna get cleared up. Let me just clear the screen. GCC. Look, this is wrong. We don't want it to print like this. We want it to print something like this. And I also forgot to delete the comma out. So for that, every time you would need a print statement which would include a new line. And make sure you don't forget your semicolon, save it, and go to your command prompt, clear the screen, compile, run. It still doesn't work. Now, why doesn't it work? The question is, there's an error in here. If you find out, you're very smart, but you have to look very closely. I'm going to give you 2 seconds to look at it. The funny thing is, there is no error in the code, but I inserted a new line in this inside printing character. You do not need that. That's what was causing the problem. So even a little piece of code could destroy whatever you're trying to do. Make sure you're very disciplined in coding, and discipline comes from practice. Let's save it. Let's run it again. Let's clear the screen. I don't want to look at this. And look at that. It's beautiful. That's how you print a pattern. But now we want to ask the user. So what I'm going to do is printf. This is the prompt. Enter the number of rows and semicolon, and then I'm going to scan it, use a format specifier, %d, number of rows, and then make sure you don't have that statement. However, you are going to declare number of rows as an int variable, and make sure you also have the address symbol in front of the number of rows in a scanf. And now save it, compile it again, no error, enter the number of rows. I say 20. No, let's just start with 2, and look at that, 2 rows printed out beautifully. Now let's compile it, let's run it again. What about 20? Now these are 20 rows. Again, oh, I'm having fun with this. 5. Oh, again, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's how you print a pattern. There are other variations for other patterns, and I'm going to teach you that in the various next lectures, so make sure you stay tuned and check out the other tutorial. Hello everybody, in this tutorial I am going to teach you how to code this pattern. Now if you haven't already watched my first pattern video, I suggest you do that because it is going to be a prerequisite for this lecture. So in this lecture we can see that we're basically reversing the pattern that we wrote in the tutorial above. So it is crucial to understand the logic behind the code. So let us make an attempt to understand the logic. So I look at this, and then I look at this, and I see that the number of column corresponds to the number of rows, but it is reversed. So basically, if I ask for number of rows here and the user enters 5, then I have to print 5 star in the first row, correct? So, and then we're going to decrement, and every time the row increases, the star decreases. So the first thing we're going to do is write a for loop, and then in the condition we're going to say column equals to number of rows. Then we're going to say go until column is less than or equal to number of rows, and then we're going to decrement column by 1. However, there is a problem with this because every time it's going to decrement, there's going to be a time it goes to -1, -2, and that's going to be a huge error. So we're going to need an if loop which says if column is less than or equal to 0, less than 0. Make sure you don't write equal to, because then it's going to be a false statement and there's going to be a big error. So if column is less than 0, break. And then we're going to write our other for loop inside this for loop. And we're going to say for row is equal to column. We're going to start a row with whatever value of column is. So if it's 5, then row is equal to 5. If it's 6, it's equal to 6. And make sure you know that column is equal to the number of rows that you enter. And then we're going to say end it whenever row is less than or equal to column. So basically, when row is less than or equal to column, it ends. And then we're going to decrement row by 1. And we're also going to have the same loop that we had here, because we can't have row going into negative. And instead of column, I'm going to change the name to row. Now I am going to write the code for this part, and it's just one statement. It says print f character C. Make sure your format specifier is of character and not of integer, and then I'm going to say star semicolon, but this is only going to print this line. For the next line, we are going to need what is known as a new line printf function. And let me just write it down. And there it is. Make sure you don't forget your semicolon. Save it. Let's compile it. Oh, there's an error. Number of rows is undeclared. Okay, I made a mistake here somewhere. Number of rows. Okay, right here. Look, I put a O, which is smaller. We need a capital O. Let me save it again. Let me compile it again. Okay, it compiled, no errors. And how many number of rows do you want? Now, look, whenever you're in a command prompt and you have this line blinking right after your question and you want it to blink right after this question or a new line, make sure you add a new line thing. It always bugs me to have that, so I'm just going to save it and I'm going to compile it again. Let me just clear this. Look, I didn't save it, so let me just, okay. Command prompt, cd desktop, and gcc pattern print.c, and then -0. No, minus O, and then the executable name. Then no errors, pattern print. How many number of rows do you want? Now you have a blinking sign right after the question and not before. So let's say 5. And look at that. 1, 2, 3, 4, 5. And it's in decreasing order. So this is how you write your code. And basically you need to understand your logic before you write your code. So make sure you always have your logic. Now if we did not have this if loops to break it out, this would not work. Just to show you, let me save it, because whenever it goes, column is going to go to 0, -1, -2, and it's going to be a huge error. So let me show you again why there's a huge error, and let me compile it. See, now it compiled because it's not a syntactical error, but it's a semantic error, so the compiler doesn't catch that. So as soon as I enter 5, it's never going to stop. The loop is always going to run. And look, it doesn't stop. It keeps running, running, running. It doesn't even get out of here because the column is 0, -1. It doesn't stop. It doesn't have any ending, because here we said end it when column is less than or equal to number of rows. However, it's always going to be less because we're decrementing it. Therefore, you do need those if statements. Now, let me just show it to you one more time so you guys don't forget. Control save. I'm going to open up a new set of command prompt. Write cd desktop, cd desktop, gcc pattern print.c pattern number of rows, say 8, and there. Okay, let's compile it again. Let's run it again. 7, and there. Then let's do it again. What if we type in 0? There's only one story if you type in 0. Look at that. That's beautiful. Let's compile it again. Let's say 1. Look, there's 2 now. You understand that? Now that's an error. But why is there an error like that? That's a semantic one, and we're going to understand that in later lectures. Until then, you know what? I want to compile it again because it's way too much fun for me right now. Let's say 5. No, let's say 50. Huge one. Look at that. That's beautiful. Alright. Alright, I'm going to see you next time. I want to play with this for another 5-10 minutes. Alright, guys.
So let's compile the code that we wrote, the hello world.c. So basically what this thing should do is just print out hello world. So first let's compile it. The structure for compilation is this. The first thing you write is gcc, then the file name exactly as you typed it. So I typed it capital HELLO, capital W, and then .c, then leave a space, then a minus sign. This sign is right next to 0 in your numbers line on your keyboard. You do not have to type shift while doing it. Just type minus, and then a O, and then hello. So let me just go over this again. The first, what we're doing is calling the GCC compiler to compile this code and save the binary code that comes after compiling this code into this hello file. So as soon as I press this, did you look at that? This is now the binary file that was the result of compilation from hello world.c. What we want to do is execute this file. Now we don't have to look at this file anymore because we already created a binary from this file, and the binary is into this file. So let's run that file. Now all we got to do is just type in hello. Make sure you type in the exact binary file name, but without the extension .exe. And look at that. The output comes out hello world, just as we wrote in the program hello world. Now if we made a mistake here, like let's see, if we forgot to type this semicolon, right? Let's save it. Now we have a mistake in our code, so it's not going to compile, right? But it is going to show you that you have an error in your program when you compile it. So let's see, GCC. Look, it shows you error right there. Hello world.c in function main error expected semicolon before the end brace token. So basically you forgot to put a semicolon in your code. So let's put our semicolon back, and let's see if we forgot to close our main body, what happens then. Now obviously that's an error, so save it, and then recompile it, still shows you another error, expected declaration or statement at the end of the input. What it means is you've pretty much forgot to close your body. And let's close it. So basically, whenever you have an error, the compiler won't compile. It will give you the error code, the name, and everything. So after you fix all the errors, compile it. See? Oh, we forgot to save it. Oh, yeah. This is also important. After you fix your errors, make sure you save your file. And then, let me compile it again. Now look at that. There is no error. And let's execute the executable file, which is hello, but Hello, hello world. It comes out. So that's the end of the lecture. If you have any questions, please do ask, and I'll see you next time. Hello everybody. In this tutorial, we're going to learn how to declare variables. But first, let's go over some previous tutorials and let's recap. So let's write our preprocessor directories. So hash, the keyword include, include smaller than sign stdio.h greater than sign. Then let's include the second preprocessor directory stdlib.h and a greater than sign. And then let's declare a main method, a main with two brackets and two braces to contain its body. And so there are three important type of variable types. The first is integer. An integer. So basically, this is how a variable is structured. The first thing you write is the variable type, or what kind of data is going to be stored in that variable type. So if it's an integer, type in int or the type, then type in your variable name. Let's type in num1 and then a semicolon to end that statement. So this is what is known as a declaration of a variable name. So let's declare another integer variable. Type in the int, it's a keyword, and then type in the value num2. So this is known as the variable name, and that is where you can store data of integer type. So basically we can store a number 52, a 53, a 54, 100, a million, but you cannot store decimal numbers in the type integer. For that you need to use double. The double. Now you can definitely use any decimals, but for the sake of simplicity in this tutorial we're not going to use double. So this is how you declare a variable. Now let's do something with these variables. Let's give them a value to store. So let's give num1 a value of 5. And never forget the semicolon. I cannot stress this more. This is what is known as an assignment statement. What you did is you assigned 5 to num1. So basically num1 holds the value 5. So let's print out the value of num1 on the screen. I know it's pretty cool. But before we do that, let's also assign num2 to a value. So num2 is equal to 4 and semicolon. Now let's print these values out. Print. For printing, remember, use the printf, then brackets. Then if you have a prompt to print, you need these two structures. If you don't have these two structures, then you cannot, it's not going to work. It's going to show an error. Now the prompt, I want to say
the value, no, num1 equals %d. Now this is what is known as a format specifier. So a format specifier is a place where the value is stored, and it's going to print the value of the variable in the place of a format specifier. So let's just do it and then you'll know. So %d, num1 equals %d, and in this %d we want to print out the value that is stored at the integer num1. So let's type in the variable num1, and don't forget the semicolon. Now let's print out the value of num2. Print f num2 equals %d, or the format specifier, and then the variable that you want to print at that format specifier, which is num2. So let's compile it. Before you compile it, make sure you save your code. So let me just save it. Save, then go to command prompt and type in my compilation statement in the command prompt. But look, my directory of this code is saved at the desktop, so I cannot just type in gcc and all the part2.c and its binary executable. I cannot do that. I first need to tell the command prompt to look into the desktop or wherever your code is. So the first thing I'm going to write is cd space capital D, desktop. Now look, it's now looking into desktop, so I am going to write down my compilation statement, gcc, then my file name, which is part2.c, then my executable name, which is going to be part2. And look, there are no errors. So now what we're going to do is we are going to compile it, run it. We already compiled it. Let's run our executable, part2. Now look at that. It says the num1 equals 5. But in the code, we never said num1 equals 5. We said num1 equals the format specifier, and the format specifier is equal to the value that is stored at num1. So basically, that's how we want to do it. And num2 equals 4. Now, if we change these values to like 100 or 20,000, we can do that. And now it's going to print those values. So let's compile it again, and let's run the executable. Oh, see, I forgot to save it. That's why it's still running the binary that we already did the first time. So make sure you always save your code. Now I saved it. Let's compile it again. Let's run the executable. And now you can see how num1 is equal to 100 and num2 equals to 20,000. Now what we're going to do is we are going to change the variable values again, and let's see what happens. And we're going to print them again so you can see how it overrides. So let's make num1 equals to 100,000 and num2 equals 200. Actually, let's just go there. Now look, the first thing the compiler will do is it's going to initialize num1, initialize num2 as a variable of int, then it's going to give them values. Then what we did here is we printed them out. We printed out their values through format specifiers, and now what we did is we assigned new values to those variables. And now let's print them out again, and let's see what values they print out. What's going to happen here is the new values are going to be
dissimilar to these values and not the values that we stored before that. This is what is known as variable override, and let's see what happens. Let's compile this. No, let's save it first. Make sure you always save your code. Let's compile it now. Oh, there is a warning. I made an error. So basically what this warning is saying is that this num2 is too big for this variable. So let's just change its value. It was too big. It was over like 20 million or 2 billion. It is too big. Other languages have their own limits. So let's change it to like 3000. And now let's save it. And let's compile it again. See, it compiled without any errors. Now let's run the executable. And look at that. The first thing, it printed out num1 and num2, and then it printed out num1 and num2 again, but those values are different because they got overridden when I assigned them new values. So this doesn't look too pleasing. It's all in one line. We want to change that. We want to have different lines for different variables and their values. So what we can do is go to our print function, and at the very end of the prompt type in \n, and what that's going to do is give a new line. So every print function I'm just going to type in \n and make sure it's in the end of the prompt but before the ending of the prompt, and a new line \n, and I'm going to save it, Control S, and let's compile and let's run. Now look at that, it changed from above. Before we added the new line \n, it looked like this, but now after we added, it looked very pleasant actually, and you can actually read it. So make sure you have a \n whenever you want a new line. If you want a tab, it's \t. So that's very useful, and we're going to use that in one of the later lectures. So in this lecture, what I want to show you is how we can assign a variable value and declare it in the same line. So basically, here I've already typed it out. I declared a variable of type int, and I also assigned it. In the previous tutorial, what we did was we declared a variable and then assigned a value. It's pretty tedious to write that again and again, so we can do that. This is one way of doing that. What we can also do is declare different variable types in the same line. So if the type of the variables is going to be int, then we type an int and the variable name num1, then a comma, then num2, then a comma, then num3, then a comma, and num4. So and then a semicolon. In this line, what I did was I declared 4 variables of type int, and we don't need to write them again and again with int num1, int num2, int num3, and int num4. We can just do this in the same line. It's very simple and it's very, very efficient. So basically, we can also have various format specifiers in the same line. So here we typed printf num1 equals num1. But what we want to do is print num1 and num2, but have that in the same line. We can do that. So let's delete this printf statement. Let's go to our first printf, and then just in our prompt type in num2 equals %d. So this is the second format specifier that we have, and for the second format specifier, we're going to define that value to num2. So basically, this format specifier is going to hold the value of the integer num1. This format specifier is going to hold the value of num2.
Also, let's have num3. Let's have 4 format specifiers so we know exactly what we're doing. %d and num4 equals %d. So basically we have 4 format specifiers. Now let's assign these guys value. Num1 is 1, num2 is 2, num3 is 3, and num4 is 4. Actually, you know what? Let's make it 11, 22, 33, and 44. And now let's print them out, num3 and num4. So basically we have 4 variables, and also we have 4 format specifiers holding each num1, num2, num3, and num4 in their values respectively. But we don't have any kind of new line or a tab in the middle. So let's use a tab this time. A tab, you can have a tab in your code by \t. So after num1 I put \t. After num2 I'm going to put \t. So what this is going to do is going to make it pleasant and make it more presentable. And that's it. And let's save it and let's compile it. So no errors. And look at that. Num1 is 11, num2 is 22, num3 is 33, and num4 is 44. Basically, all our format specifiers have a value, and each value has its own type. Now, what if we do not want to change the value of num2 in the entire program? What we do is type in const when we're declaring them. We type in const, constant. What this means is the values of num1, num2, num3, and num4, once they're assigned a value, they are never going to change ever. You cannot assign it a different value in the later code and give it a new value. You cannot do that. That's illegal. And I'm going to just show you in a minute. Let's save this. Before we do that, let's actually try to assign it a different value. And we try to change num1 to 22, and let's just print the value of num1. Sorry, my caps lock is on. I turned it off. And let's put a format specifier and num1 and a semicolon. Don't forget the semicolon. And let's save it and let's compile. See, there is a problem. This assignment is a read-only variable. You cannot change it. So basically, whenever you're typing a constant, make sure you don't have various variables in the one line. Let's delete that. Let's try to do this. Let's assign this value. Actually, let's just change it to pi. It makes more sense. Pi is 3.1. Nope. Then actually, let's use constant, and let's use a type of double, because pi is 3.14, and you cannot use that to store in an int 3.14. Now let's delete this and let's print out the value of num1. And then let's try to change pi. Oh, I have to change all my, remember I have to change all my variable names wherever I assign them. Pi, and now I change my value of pi to 22, and pi. So whenever you're declaring a constant type of variable, its value is never going to change. And if you try to change it, it's going to be illegal and it's going to show you an error. So let's try to do that. Now let's clear the screen and compile. Look at that. Assignment of read-only variable pi. You cannot change the value of pi. You can read it, meaning you can print out the value of pi, but once it's declared a constant type, you cannot change its value. So let's delete that and now save it. Let's compile it. And look at that, it compiled. And let's run it. Pi is that. Now you might be wondering, okay, pi is not 137438955, whatever that is. Pi is not that. The reason for that is that we cannot use the same format specifier for the type double. There's a different format specifier for that. The other format specifier for the type double is %f. It's not %d is used for int. We are using type double, so we're going to need %f. Let's save it and let's compile it again. Now look at that. It printed out the value of pi and some zeros in the back. Now those zeros have a meaning, and I'm going to show you that in the later lectures. Just remember, the purpose of this lecture was to introduce you to double and constant. So I'll see you next time. Hey guys, in this lecture we're going to add two numbers and save it in a variable. So let's start by declaring two variables, num1 and num2, and then let's assign num1 to 16 and num2 to 50. Now what we want to do is we want to add them, but we can't just add them. When the addition is done, we have to save that value in a variable. So we're going to declare that variable as result, or actually, yeah, result, and then we're going to set that equal to the value of num1 plus the value of num2 and a semicolon. Now the result is the addition of num1 and num2. Let's actually print it out so we know. Printf num1 plus num2 equals, and don't forget the format specifier is %d because it's the type int, and we're gonna assign that to the variable result, semicolon, and print. Now what we want to do is we also want to multiply them. So let's result equals num1 times multiply. Now the multiply sign is on 8, so type in shift 8 and you'll have the multiplication sign, and num2. Also don't forget the semicolon. Now it's also going to be type int because we're multiplying two ints, and we are going to print its value. Don't forget to change it. Now let's divide them. So assign result to num1, divide num2, and a semicolon. In this cases, it's better to have two brackets to make it clear. And now let's print it. And so we did add, multiply, and divide. Although we forgot to subtract. Oh, I was wondering, what am I forgetting? Okay, so let's assign result to num2 minus num1, or num1 minus num2, it doesn't matter. And a semicolon, let's print it out. and let's have minus. And also we want to make it pleasant so a reader can read it, so make sure you have \n for the new line in every single code prompt, and \n and let's save it. Let's go to our command prompt, compile. Oh, thank God there are no errors. Okay. And let's execute the executable, and look at that. num1 plus num2 is 66. The division, however, is 0. That's because when you divide two ints, like when I divided 16 divided by 50, the result is in double, and we have it in int, which is wrong. We cannot have that. We can only save that value in the type double. That's why it says it's 0 and it forgot all the decimals. So let's fix that. Let me show you how it's done. So let's double. Actually, let's use float. Oh, this is subtraction. I shouldn't touch this. We should be doing double. Float is also a type double, but it usually holds more value after the decimals. So let's save it. And make sure you have the format specifier to %f. I forgot that. Let's do that. Okay, and save it. And let's run it. Oh, there's an error. Oh, okay. You cannot have the same variable types even though they have different variable types. So basically you cannot have the same variable names in the different types. So let's make this result1, Control S, compilation. There's no error anymore. Port 2, right there, 0.00000. Well, oh, so basically what you need is you need to have the bigger number the top and the smaller number on the bottom, so you know it's balanced. Now what it's going to do is it's going to give you the answer 3 when you execute the code for division. Why? Because it's type float and it only stores some particular value, and I'm going to show you why it does that in the lectures ahead. I cannot show you that right now because you don't have the requisites or prerequisites right now. So yeah, let's compile this code. Let's compile. Oh, did I save it? Save and compile. No errors. And execute. So num1 plus num2 is 66. Num1 times num2 is 800. Num2 divided by num1 is 3. As I said, it's going to be 3, and I will show you why it's 3 in the later lessons. And num1 minus num2 is -34. Alright, so let's clear the screen, and I will see you next time with a tutorial on comments. They're very important. So see you next time. Bye bye. Hello everybody. In this tutorial I am going to show you what comments are. Comments are basically notes for other programmers. It is a very good practice to write comments whenever you're writing code for complex statements. So we don't have any complex statements yet, but I'm still going to show you how to write comments. So the first way is to type // and then your text. This is a comment.
a comment doesn't affect the code at all. It's just there for other people to look at your code and understand it. So this is the first way to write a comment. This slash slash, whatever comes after it, it's going to be a comment, but only in that line. So basically, if you want to comment here, you can again type in slash slash and comment. But if you want this whole thing to be a comment, or this 2 lines to be a comment, what you do is you type in slash, then shift 8 or star, and then this is initializing a comment, by the way, and then you need to end your comment. And what you can do is press shift 8 and then a slash again. So you start a comment with a slash and then a star, and you end with a star and then slash. Basically reverse it. Comments are very useful, and you're going to learn that comments can actually improve your code status in the later lectures. So if you're still confused about comments, let me make it clear for you. So we commented out the 14th, 15th, and the 16th line, which basically adds num1 to num2 and then stores that in the variable result. Actually, let's just comment out the whole 14 to 18 line, and when a compiler sees a comment, it basically ignores it because it knows it's not a code, it's a note. And so now when we execute our main method, or we run the program, it's going to ignore these 3 statements. So let's compile, let's run. Look, it completely ignored num1 plus num2 and printing out num1 plus num2 because we commented it out. Now comments are very useful when you're writing code and you do not want to run that part of a code in that section. This is very useful when you have huge programs and you need to check the functionality of a section of a code and you need to ignore some other part of code. You can just comment it out and not delete the whole thing and type it again. So basically that's where you use comments. You can also use it for notes between lines and their statements and their functionality. So we're going to learn more about comments in the later lectures, but that's it for now. Thank you for watching. Hello everybody. In this tutorial I am going to teach you how to add num3 to result, but not in a common way like this. Everyone can do that. There is a more efficient way you can use this, and this is going to be very helpful in the later chapters on loops. So the first thing we need to comment this thing out because we don't need that in our code right now. So let's comment this whole slew of code out. So slash star, and let's end our comment with a star slash, basically reverse. Now we want to add num3 to our result. We can do that by assigning result equals result plus num3. So now what it's going to do is it's going to save the value of result to result plus num3. Let's assign num3 to like 100 and let's print this out. Also let's just copy paste this so it's clear for everybody. Equals save and compile. execute, and right there, result equals result plus num3. So the result is 166. What it did was the result was num1 plus num2. Then what it did was assign result to result plus num3. So basically, result stored the value of addition between result and num3. There's a more efficient way you can do this, and that is result SULT plus equals num3. We don't need this slew of code now, so let's just delete that. This statement, what it does, it's basically a clone of this statement right here, equals result plus num3. So what it says is take result, add result to num3, and then save it back to result. That's all it says. It basically says the same thing that what we wrote like 2 seconds ago. Now let's print the value of the result so it is very clear for you. Equals, don't forget this format specifier, save it. I saved it, Control S. Let's compile. There's an error. Oh, I forgot to put a semicolon in this statement. Now let's save it again. Let's compile. And that's wonderful. The result after adding num3 is 166. That's one very efficient way you can do that, and there are various other ways you can do it, and I will teach you those ways in the later lectures. Those are not necessary right now. So remember, however, hi guys, in this tutorial I am going to teach you the scanf function, which basically takes your keyboard input and stores it in a variable. And I'm also going to teach you about if-else loops. So let's get started. The first thing we want to do is declare two variables, num1 and num2. The second thing we want to do is we want to ask the user what those values are. Basically, we're asking the user to enter num1 semicolon, and now we're going to use the scanf function. Scanf function is just like the print function, so whenever you have to use format specifier in the scanf in the printf function, the similar structure is used in the scanf function, %d, and then you save that format specifier and link it to the variable you want to save it. However, you need an address sign before the variable. So what this statement is saying is, take the address of num1 and store the value provided in the format specifier that you just entered and save it to that address. Now we want the user to enter num2. So let's write the prompt, enter num2, and write the scanf function again. Make sure your format specifier is in the string structure. So %d, also num2, but do not forget the address sign. Let me make it clear again. What this statement is saying is, whatever the user just entered, save that into a format specifier and then link that to the address of num2. Now the num2 is going to be whatever you enter. So whatever you guys entered, let's just print it out so we know. Printf num1 equals format specifier %d. Let's tab it, \t, num2 equals %d, and then num1 and num2. You only need this address symbol in front of the variables when you're using scanf functions or using pointers. Pointers, you guys are not going to use it until the very end of the series, so you don't have to worry about them. So let's save it and let's compile it. So there are no errors. Enter num1, 25, enter num2, 26. Num1 is 25, num2 is 26, but this is not presentable, so let's just add a new line. \n, \n, and let's save it, compile it, and enter num1, 25, 26. Num1 is 25, num2 is 26. That's how you get user input from the keyboard, by using scanf function. Make sure you understand what scanf function is. It is very important. Also, don't forget to put the address symbol in front of the variable names that you're trying to store in only scanf function. You do not have to put that address symbol in the printf function. So that's that. Thank you for watching, and I will see you next time.